Hi all. Many of you have reached out to me to establish a proof point whether EKS, which is running in the AWS public cloud, can be integrated with Dell's offering, which is Apex block storage on AWS, whether it's possible or not. The answer is simple. It's a resounding yes, yes, yes. And in this blog, we will establish that as a proof point to a practical demonstration of how easy it can be to deploy the CSI drivers and persistent workloads on EKS, which will consume the Apex block storage from or running on AWS. Now, point to be noted is whether it's running on premises or in the cloud, PowerFlex remains the substrate as the software-defined storage framework for Apex block storage on AWS. The technology is 100% parity, whether, like I said, it runs on premises or in the public cloud. When in the public cloud, the offering is labeled as Apex block storage for AWS. Now, what I'll do is I've already written the blog. So in order to make sure that we follow and we are utmost sure of the procedures, I will simply go ahead and copy paste the commands from the blog itself and then build an EKS cluster and then deploy the CSI driver on the EKS cluster that will talk to the Apex block storage running inside of AWS. Without further delay, let me share my screen. You can see the blog is already published on Medium and the link will be provided. But it says integrating the behemoths, right? I mean, both are massive beasts in their own sense with the potent EKS and Dell's Apex block storage for AWS. Now let's run through the scenario very quickly here. You can see that I have a VPC running inside of AWS with 3 subnets here across 3 different availability zones. We will deploy an Amazon EKS cluster along with a worker node group, which is not based on BottleRocket because BottleRocket will not allow me to do any customizations. And in this case, we need the software defined client for Dell's Apex block storage or PowerFlex, right? To be implemented on all the worker nodes actually. This software defined client is more or less like an iSCSI client or an NFS client, but this is specific to the PowerFlex technology actually. So in order to actually deploy this through a bootstrapping mechanism, we will be running Canonical's Ubuntu 2204 AMI, and which is based off for the latest version of Kubernetes, which is 1.29 as of this writing. So let's also look at my AWS console here. You can see that there are 3 storage nodes running, which mimics the Apex block storage inside of AWS, as opposed to EBS or any other storage provider. Cumulatively, this creates the PowerFlex 45 cluster, which, like I said, resembles the Apex block storage offering inside of AWS. Now, going forward in this video, I will simply call this storage offering as PowerFlex 45. Else I'm gonna, wither away with my words here and there. Okay, so here is the storage cluster, and this is running on 3 EC2 instances, which are of the type C44X large actually. Also, let's see that. Okay, I'm in the Ireland region for you to be sure. I already have 3 EKS clusters. Okay, the one that we are going to deploy is going to be a brand new one, so don't worry about it. So as of now, the baseline is that we have 3 EKS clusters. Now let's hop on to creating the EKS cluster itself actually. So I'm going to use this Ubuntu terminal here. Don't worry about this is a local machine I have, which has a connectivity to my AWS region through a direct connect. So all good there. Okay. So what we will do is we will start creating the cluster like I said. Again, I've given the specifics in the blog itself. And as such, the video demonstration and the blog itself, like I've mentioned, it's a slightly longish. I wanted to make sure that, the audience receives a full, in-depth understanding of how this is done. But for a usual case, when you ought to deploy it, this is like a regular job and should not take much time, actually, given that there are only 3 things to be done. One is create the EKS cluster and the node group templates, create the cluster itself and the node group, and then using a highly automated script, we will deploy the CSI driver. That's about it, actually, right? But again, I've made sure that everything is captured in detail. As of now, we will first start with declaring a variable and creating the cluster directory. So let's do that. Okay, so my cluster name, I'm going to keep it as EKS Apex Block Test 1, whatever it is, right? So you could name it anything. Now, once the directory is created, we will download the template. I've already stored the template in my GitHub repository, and I'll actually talk to you about the template itself. So let's download this template and save it in the clusters directory. Okay, with the cluster name itself as the prefix for the YAML file. Okay, so the file is downloaded and it has been renamed as the, let's see what is the name that it's come to. So CD cluster name. Okay. So you can see that we have the cluster template, which has been generated inside of this. It's just the YAML template that has been downloaded, and we've just renamed the template here. Now, what I'm going to do is we'll walk through a quick, observation of this template. So let's do that. And I'll tell you basically what it has. So the name of the cluster, I've already mentioned it as EKS block Apex Block Test 1. You could name it differently, so just make sure that you edit it. The region in my case is EU West, and the version, like I said, it's 1.29, which is the latest as of this writing. I already have a VPC in which I'm going to deploy this particular cluster. Okay, and most importantly, the makeup of my VPC is that it's a private VPC. It's a highly regulated or constrained VPC, which is like any other typical enterprise. So in order to gain access to the EKS cluster or the API server, I have to ensure that the private access true has to be mentioned there. And other than that, so you could change it depending upon how constrained your environment is. Other than that, the subnets in which my cluster nodes will be placed are mentioned here. This is all subject to change depending upon one's environment here. Okay, so far so good. Let's now use this template to create the EKS cluster. And again, I'm not doing anything, surprisingly different here. People who are used to doing this day in, day out would realize that this is a bare bones template. This does not have any node groups as of now. So no nodes will be created. It's just turning on the control plane inside of EKS. I'm pretty much confident with or comfortable with EKS CTL, which is the a very easy CLI to work with EKS. You could use any other form of creating EKS clusters. It could be the GUI, it could be the Terraform provider or whatever, right? So in my case, I'm just going to create the EKS cluster. Again, this is the control plane creation, okay? And I'm going to place the kubeconfig in the clusters directory itself with the prefix being the cluster name. So let's do that, okay? So you can see that the cluster creation has started. It'll take roughly about 7 to 8 minutes, more or less, depending upon what's happening in the background. So allow me to pause the video and resume when the cluster is fully created. So we can now see that the cluster is ready. The cluster with the name EKS Apex Block Test 1 in EU West 1 region is ready. Okay. let's also validate this EKS cluster from the AWS console. Let me refresh this screen. Okay, cool. So we have the cluster, it's running 1.29, which is the latest version. The provider is EKS. So as of now, the cluster is a bare bones cluster. Like I said, it does not bear any nodes, and we will create the node group. But before we do that, let's set the kubectl context here. Let me do that. Okay, let me refresh this page a little. Okay, now that we have this, yeah, let's take this kubeconfig. We're just setting the context and we will see if we can get the nodes. There are none, so there will be 0 nodes in the output. So you can see that although, we've set the kubeconfig, although my kubectl is able to communicate with the EKS control plane, and it says no resources found. So at least it's not erroring out, which means that the EKS control plane is working actually. So like I said, there are no nodes, so no resources found. So now that our EKS cluster is created and it's without a node group as such, there are no worker nodes in that. So now it's time to create or download a template for a node group, edit it, and then start deploying the node group itself. One important consideration would be for node group creation is which is the version of Kubernetes that one is planning to run inside of EKS. Here we have deployed 1.29 as the Kubernetes version, which uses the Canonical's Ubuntu AMI. And that AMI for 1.29 and above is based on Ubuntu 22.04 OS. While if you plan to run the same deployment or a node group for Kubernetes version 1.28 and below, then the default OS for the worker nodes based on which Canonical AMI is built is 20.04. Now that's a primary difference. I have made sure that in the blog, I have rendered this particular description so that you understand what's going to happen differently if you run 1.29, 1.28 and below or 1.29 and above. So there are 2 different cluster templates that I maintain. You can see this, one for 1.28 and below and one for. So in this particular case, since we have the cluster running 1.29, I'm going to take this set of commands, okay, and download the node group template into the cluster directory. Okay, so let's go to the cluster directory and we can verify that this particular node group template has been downloaded and saved with the prefix of cluster name. Now, if I read into this particular YAML for our node group, one thing that bothers me, but we have to live with it, that although this particular AMI is based on 22.04, EKS CTL as of now does not recognize that as a AMI family field. But I don't know what's the thing there. I can confirm to you, at least on the Ubuntu's description from the official homepage and the AMI loading on the catalog, that this AMI is based on 22.04 actually. But it still works. So I've gone ahead, naming the AMI family as 20.04. It still works actually. I don't know what's happening in the background. But nevertheless, I think let's read through the node template or node group template. I have the name of the cluster to which this particular node group will be attached, which is our cluster name, block test 1, the region. I put in a label with the key being group and MD0 to make sure that when the CSI drivers are deployed, they rightly target this particular node group with the affinity of this or association of this label key value actually. So if you have an existing cluster and node groups already doing some other roles, we don't want to make sure that the CSI drivers wrongly get deployed on some other existing production node groups actually. So these set of label will actually help us prevent that. The instance type you can change, AMI family and AMI I've already spoken to you about. I've also made a description of that. You can go here on the Ubuntu's page, find out the right AMI for your Kubernetes version of EKS and the region in which you are running this basically. And that's mainly that's about it from a configuration here. The private networking true is for the fact that my EKS cluster, the node group will be running in a private subnet frame, private subnet. So this has to be populated. The number of EC2 instances for the group, blah blah blah. Okay, so pretty standard. This is where it gets interesting, since this is based on a custom AMI, which is the Canonical's Ubuntu AMI for EKS as opposed to Bottle Rocket. We do have to supply some of the override bootstrapping commands. Now, this is not my suggestion. This is how EKS CTL actually wants it to happen. So you can read it more on this particular URL I've provided here. You got to run a bootstrap helper script, which will advertise certain variables and things like that. And then, for the custom AMI to function properly, you need to actually supply this particular command to run the bootstrap script. Now, these scripts are not maintained or managed by me. This is all EKS CTL doing things in the background. But we have to go ahead with this and then, write these particular or execute these particular commands here. This is where things are required for the PowerFlex SDC deployment. Now, PowerFlex SDC is the software defined client that communicates with the PowerFlex software defined storage running inside of AWS as Apex block over AWS. Like iSCSI or NFS client, there is a SDC which is required for this particular communication from the client to the PowerFlex storage nodes. So we are based on the Ubuntu OS. In this case, it's 2204. So you can see that we are actually fetching a script which is EKS SDC Ubuntu 2204. I maintain this script on my one of my GitHub repositories. So all we got to do is basically identify if you are running EKS 1.28 and below. So the value of the script will change, or the name of the script will change to EKS SDC Ubuntu 2004.sh as opposed to 2204. Nevertheless, I think all of us at some point will be and need to upgrade to 1.29 Kubernetes. So let's go ahead with this particular set of commands. So I'm retrieving this particular script. The only change that we need to do is basically change the set of IP addresses which belong to the metadata managers. Now this is, I think if you've worked with PowerFlex earlier, or if not, there's a set of component functionality within the PowerFlex called as metadata managers. It helps orchestrate the PowerFlex cluster, the software defined storage cluster, from an information and state operations and all that actually. And generally these metadata managers are a component functionality within the cluster actually. So what we are trying to do is basically, once we've retrieved the script here, just change, I've put in a placeholder text called as MDF-IP addresses in the script. We're just kind of changing that with the value of the actual MDM IP addresses. And now whatever that could be or mean for your environment, you just change it there. Other than that, pretty much everything is standard here. We just making sure the host name and the Kubernetes node name are similar or same, because that's one of the requirements for the CSI driver installation. And finally, we run the SDC client installation script. So pretty much, if you have to deploy this, you go change things as per your environment here. Okay, that's in the node group variables, and then change the value of the MDM IP addresses. That's about it actually. Now, once we are done with this, we will now start to deploy let's take this from the blog. So we've done this. I've made sure that, whatever we discussed or I've briefed you about is documented here, just in case, you want to cite it. We will go ahead and create the node group using the template we just read. Clear the screen here, go back, directory, and run this. So essentially we ran one command to create the cluster, and now the next command to create the node group. Let's do that. So as you can see that we've started the creation of the node group. Again, it could take anywhere from 7 to 10 minutes. So I'll resume when the whole thing has been completed, and we'll do some observations there. So we can see that the node group has been created with the template that we have provided, and we've just changed a few variables. I mean, in your case, we would change that. Basically, we've created a node group that is based on the canonical Ubuntu 2204 AMI for EKS running Kubernetes version 1.29. Okay. So now these are the two nodes that have been created with the IP of 185 and .9 actually. Let's validate this quickly. I hope I've set the config file. Let me do that if not done yet. Okay. Let's retrieve the node information. Okay. I'm just going to repaste the config setting and see if we can retrieve the nodes here. So you can see that the two nodes are visible with the IP of 172.26.2.185 and 2.9. They're running in EU West 1. They are running as internal nodes in the private subnet. The version is 1.29. The status is ready. So we are all good to go. Let's also observe these nodes from the cluster standpoint. So let's go into the cluster here. Okay, let me just... Okay, so let's see the cluster compute. So we saw that the two nodes with the IP of 185 and .9. Let's view this in the console. So we can see that the two nodes are also seen in the nodes here, right? So we are all good to go. Now, as of now, we just have a EKS cluster with a node group, and the PowerFlex SDC was installed as the part of the bootstrap script that we had rendered actually in the override bootstrap command actually. Now, how do we validate whether the SDC, which was installed on the EKS worker nodes, which are these two nodes, can actually now communicate or has a successful communication with the PowerFlex 4.5 storage cluster, which is running inside of AWS as Apex block over AWS offering. So to do that, we will quickly go over to the blog and see what has to be done. We will SSH into these two nodes, and this is just to validate, actually nothing else, but it's important to validate those things actually. So we have this, we verified this, okay, yeah. Now you can see that we will log into those two nodes with the IP address of the node. The default password, like I said, in the bootstrap was maintained as Ubuntu for the Ubuntu user and for the root user. Now you can change it to whatever you like. For now, I'm keeping it simple as Ubuntu, root, and Ubuntu. Now let's do a quick validation. I will SSH into both of these two nodes. Search Ubuntu at the rate 172.26.2.185. Okay, So you can see that I am successfully logged in into this particular node. Now there is a set of PowerFlex commands or commands specific to the PowerFlex technology that we need to run to validate this connectivity from the SDC running on a worker node to the PowerFlex cluster actually inside of AWS. Let's pick up that command. I'm making sure that I'm following the blog so that, in case you plan to experiment with this, you can do that on your own terms actually. So as a part of the bootstrap, we also downloaded a handy script. So we will just run this particular script, get PowerFlex info.sh on this particular worker node. So you can see that as long as you're getting this output, which means the SDC that runs on this worker node is able to talk to the PowerFlex cluster, which bears a system ID of this, and the MDM IPs that it can successfully communicate are these. Now, this particular value is of utmost importance because when we deploy the CSI driver, the driver installation expects this system ID to be provided as a part of the input actually, along with these MDM IP addresses. We'll do all of that. For now, let's log in into the other node, which is, I believe, .9. Okay, I have a previous key footprint. Let me remove that. Okay, let's log in to the second node. We are able to log in. So let's just run the script here to get the PowerFlex info. So you can see that on both the worker nodes, the SDC is able to communicate with the PowerFlex. And this we are validating through a script from the worker node end, from the OS itself. Now we can also validate this from the PowerFlex GUI. Now, PowerFlex GUI is a very powerful tool, let's say, in order to kind of manage the the PowerFlex in software-defined storage and things like that. So, as you can see, I am going to log in into the GUI, which is called as the PowerFlex Manager. This is managing the storage deployment or the storage nodes running inside of the AWS cluster. So let me do this. Okay. Now there are various ways of managing PowerFlex. You could use Terraform. You could use Apex Navigator for Kubernetes from Dell. Here I'm using the most, I would say not primitive, but the most typical uniform method, which is the GUI PowerFlex Manager actually. It's a very, very comprehensive tool to actually look into all the aspects of PowerFlex. Now, for now, we will go to hosts. Okay. Now, this one is my previous SDC. It's a small Ubuntu machine, which is logged in as the client. I use it for testing. But what interests us is these two row entries. You can see that 172.26.2.9 and 172.26.2.185. Now, these are the two SDCs that have been successfully registered with the PowerFlex storage running, here actually. So this kind of concludes a part of this blog where we've created a bare bones cluster. We've bootstrapped a node group of EKS worker nodes with Canonical's Ubuntu AMI for 2204 running Kubernetes version 1.29. And as a part of that bootstrapping, we've installed the SDC for the PowerFlex software-defined storage, and we are able to validate that these two nodes are indeed a part of the PowerFlex software-defined storage cluster. Now, once this stage is complete, and you could see that although I've elaborated in greater detail, it just took like 2 or 3 commands that we had to run to actually deploy the node pool and things like that. That's about it. Now, from here on, we will get onto the part where we will install the CSI driver itself. Note that the SDC is just a client, like an iSCSI client. In order for us to deploy persistent workloads inside of Kubernetes, we need to have the CSI drivers, and it could be for any underlying storage provider. It could be EBS, it could be AFS, and in this case, the storage provider happens to be the PowerFlex 4.5 running inside of AWS. So let's do that. So now, in order to deploy the CSI driver with everything that is ready for us, the cluster is there, the nodes are configured with the SDC, and they are properly communicating, we will download one script. Again, if you go to the PowerFlex CSI homepage, you will see a set of procedure which you can do manually, like creating a secret, editing the secret, deploying that secret, and that secret would basically mean that you feed in the information for the CSI drivers to be able to communicate to the respective PowerFlex software defined storage. And we got to create that secret. You have to install the CSI driver itself through Helm or some other mechanism, the operator mechanism. So there are all those steps are documented, well documented on the homepage. Plus, most of the storage, CSI avenues that you engage, typically you would also need external snapshotter for supporting volume snapshots and things like that. The storage class, the volume snapshot storage class. So in order to facilitate a simpler way of doing it, I kind of automated all that into a small script, which, if you supply the right inputs, will automatically deploy the external snapshotter on the EKS cluster worker nodes. It will also deploy the secret required actually for the communication, secure communication. It will also create the storage class, the volume snapshot class. So all that in one simple script. And I think let's see that in action actually. So let's go back to the blog. Okay, we verified all this. And like I said, we have to take care of we need to make sure that the system ID is known to us, okay, and the MDM IP addresses. Now, I've also shown you this. Yeah, we can also see this in the verify this IP addresses in the EC2 console for the worker node, but I think that's a redundant step. We can just omit that. We are good up till now. Some things that are important in terms of, if you recall, I had mentioned that you will need to associate your CSI drivers with the, the label of group equal to MD0. So I've just mentioned done a quick mention of that. Now, the script that we are going to use to deploy the CSI driver has been, I've just put it into one of my repositories. It's on EKS Anywhere repository, but what the hell? I mean, I just thought it's better to kind of co-locate that because it's EKS, so EKS Anywhere. So I've just put it in there. You can retrieve this through the set of command, okay? And then we can make the script executable here, okay? So let's do that. Let's take these two commands, download the script and make it executable. So I'm gonna put it here, not here, I'm still inside the node. Let me go back to my machine. Yes, cleared this, I'll need the system ID. Okay. So now that we have this particular script running there, let me go into the directory and validate this. Okay, we do have the script here along with the other files. And I'm gonna do one thing. I'm just gonna copy this in the home directory itself. Okay, so that, okay. Now, I will run this particular script. And let me run it from the cluster directory itself. Sorry, I'm just going a little bit back and forth. Install. Okay, so let's put this script in play. So the first thing that it asks us is what is the cluster name that we will deploy it on. The importance of placing this attribute here in the script as an input is, when the volumes get created, we can prefix the volumes as seen in the PowerFlex GUI with the cluster name itself. So you can apply any prefix. Here I'm choosing to apply the cluster name as the prefix so that we can easily, if you have 100 odd volumes, you can easily see which one and then filter out and all that actually. So our cluster name is EKS Apex block test -1. Okay, EKS Apex block test. Okay, so once the cluster name is provided, then it expects. So there is a certain release management that happens for the CSI drivers, and this is a part of the official CSI maintenance that we do at Dell. And obviously, as Kubernetes evolves, so do many other things. So in order to keep pace with different versions of Kubernetes, we make sure that we keep a tight alignment with the how the Kubernetes roadmap evolves actually. So as of now, the latest as of this blog, the latest CSI driver version is 2.9.2. So I'm just going to pick that as the version that I will choose to deploy as the CSI release number. Okay. Then comes what is the IP or the FQDN of the PowerFlex cluster. Okay. Now this is not the MDM IP addresses. This is basically the endpoint through which we access the PowerFlex. And in this case, you can see that this is the URL here that I use to access the PowerFlex cluster. This DNS setting actually translates to a IP address. So I'm just going to put that from my memory here. Okay, so this is that IP address. Now, next input is the IP addresses of the MDMs. So as you can see that this output here from our worker node highlights that these are the MDM IP addresses, right? So we will need to provide a comma separated value instead of a space separated value. So I'm just gonna take this values 124, 26.2.125, 26.2.126. Okay. Now, once I have supplied the MDM values or the IP addresses, the next it is asking me for the system ID of the PowerFlex cluster. And this is the system ID of the PowerFlex cluster. Username for the PowerFlex cluster. So I need to have the authorized user for it to be able to communicate, for the drivers to talk to the PowerFlex SDS. Let me put that, and the password. Obviously, it's scripted in a way that it does not reveal the password on screen. So it's just a silent entry. Now, this is important, the node selector group name. So I'm just going to put it MD-0. If you remember, the group equal to MD-0 was the label that we provide. The group is implicit. I've mentioned it in the blog. Don't change the key name itself, the group, but value you can change if you had kept it some, XYZ-0. So that would be the value here. Here during the node group creation, we've kept it as MD-0. So MD-0. Now, once the script starts executing itself, you can see that the external snapshotter implementation is being done. Next is basically the secret has been created for the VxFlex OS. So yeah, one other thing, most of the things, at least as of today, PowerFlex was historically known as VxFlex OS. So that naming continues to be there in Dell as of now. I don't know when it will change, but you will see a lot of terminology with regards to PowerFlex as VxFlex OS. So the namespace and things like that, right? So I've just retained, I haven't changed anything there. So the secret is created, the drivers are deployed, the storage class is created, and the volume snapshot class is created as well. Let's validate all of this, because it's one thing to run the script successfully and another to see it in action. So kubectl get pods minus n VxFlex OS. Like I said, VxFlex OS is the namespace for the CSI driver pods for PowerScale to be hosted. Let's see that. You can see that all the 4 pods are successfully running. And each of these pods, for example, the controller pod has 5 containers in it: driver, registrar, I keep forgetting the names, but 5 containers actually that do different kind of roles inside of the pod. So all those are ready and they are running successfully. Likewise, for the node pods, there are 2 containers and they are both in, I think, driver and registrar. They are both in running status. So far so good. We can also see, because they are in running status, means that the secret configuration is also successfully done. So let's validate that. If the secret exists, you can see that the VxFlex OS config secret is there. Now the next thing would be to see the storage class. kubectl get storage class. So you can see that the new storage class has come up. It's called as I have named it as PowerFlex SC. Unfortunately, I have not, both of them I have forgotten to delete the previous storage class that comes bundled with, the EKS, which is based on GP2. I really don't assume that we generally use this. Either we use EBS, EFS, or in this case, I'm planning to make the PowerFlex SC as the default storage class. You can see the provisioner for that is the CSI driver for VxFlex, which is nothing but the PowerScale CSI driver. Okay. Now this is done. Let's also see the volume snapshot class. Okay. You can see that there is a VxFlex OS-snap class based on the same driver of PowerFlex CSI. So now, if we create any persistent volume, okay, with this particular storage class, obviously it's going to be deployed on the PowerFlex software defined storage. If we create a snapshot with this as the volume snapshot class, it's going to show up as a snapshot storage volume on the PowerFlex software defined storage. So this concludes basically a large part of, we've created the cluster, the node pool with the requisites, and then have also deployed the CSI driver on the the worker nodes. Actually, we can also validate this from the EKS console itself if one is interested. So if you go to the resources in the cluster here, we can see that under storage, let's look at the pods here. The pods will be, let me refresh this. Okay. So we can see the namespace VxFlex OS and the controller and those pods. We can also actually look at kube system namespace, and you will see that alongside the other pods, we also have snapshot controller. So this I forgot to show you on the console, but or the terminal. But since I told you that the external snapshotter, which is a GitHub project, open source, is also deployed as a part of the script, basically, right? And that aids the creation of snapshots as we will experiment with them. So the snapshot controllers are also deployed here. We can also verify them here. Shouldn't be any different. kubectl get pods -n kube system. And we can see the 2 snapshot controllers here. Now, interestingly, we can, or we should actually validate kubectl get pods -n VxFlex OS. Oops, sorry. OS VxFlex OS. And if I was to describe the controller pod, I should be able to see the node group. In this case, we just have one node group here. So obviously, when the pods are deployed, they will come up on those worker nodes. But if you had multiple node groups, some of your other node groups doing something else. By virtue of the node group label, we should, since we've targeted it on the worker node that we've created, we should be able to see those node group labels on our pod. So let's see that. kubectl describe. Let's go here and describe one of the controller pods. vxflex. Okay. Sorry. Describe pod. Okay. So you can see the node selector is in fact group MD0, which means that anytime the pod has to be scheduled or deployed, it will check for this node selector. And if the worker nodes with this label exist, only then it will schedule the pod or deploy it on those. So it's just to ensure that the targeted placement of these CSI drivers occur rightfully. We can also see this for the node pods. kubectl get pods again, and let's describe kubectl describe pod. Let's take one of the node pods, vxflex OS. And the same thing here, you can see this here. Okay, so all good, clear. Okay, so now the next step, obviously in the course, would be to deploy a sample workload that leverages the storage class PowerFlex-SC that, as a result, in the underlying schema, uses the CSI drivers for the PowerFlex and validate the creation of the PVCs, the workload itself, do some testing and things like that. So we'll come back to that, use case testing now. Okay. So now let's continue with that use case testing that I just described, with the creation of a MySQL sample pod, which will be persisted over the PowerFlex Software Defined storage through the CSI mechanism using the storage class of PowerFlex-SC, right? And now, if we were to go back to my blog, I want to make sure that so we finished this particular point. We ran this particular script for the creation of the CSI drivers. We provided all the right inputs, and then we ran the script. And as a result of that, so we finished this part. We validated the CSI deployment and everything, and you saw that it was really quick. As long as you provide the right inputs, there should not be a challenge deploying the CSI drivers. Okay, so we've done all this, and we roll to the point where we now do a use case testing. So let's just go here. All this is documented for your perspective. This is all done. Okay, yeah. So now the point is that we can use the CSI driver. Now the CSI driver for PowerFlex supports both dynamic provisioning and static provisioning. Okay. Dynamic provisioning would mean that I would just create the PVC, and as a result of that, the volume will be created in the backend with the persistent volume and the volume in the PowerFlex. That's a very easily supported use case. I have done it in a different blog of the hybrid, data plane. So I'll omit that part. Here we'll look at the primitives to understand the functionality. So let's observe the static provisioning. So we will go to the PowerFlex GUI and create a volume. Okay, to start with. Okay. Now I will log in here. This is the PowerFlex GUI. Although I'm using the GUI to create a volume, in one of my other blogs, I have used Terraform, which is like a simple Terraform deployment template to create n number of volumes into PowerFlex, right? So it's as easy as that. Likewise, in the GUI, so I already have an existing volume from some previous use case. let's just skip this one. We will just create a volume. Okay, let's name the volume, let's say as Apex block test 1. In the blog, I don't know what I mentioned. Let me see what I mentioned it in the blog. Possibly follow the same. Okay, MySQL static provision volume. Okay, fine. Let's keep it this one then. MySQL static provision volume. MySQL static provision volume. I mean, I can name it anything. Let's keep it as this to align with the blog content. We can do thin and thick provisioning, whichever suits us. But this is another clear call out for the benefits of PowerFlex running inside of AWS, where you are not constrained by a typical EBS way of doing things, and you can actually go ahead and do thin provisioning so that you can plan and optimize your costs in the cloud accordingly, right? Now, the storage pool, which is a PowerFlex terminology, I'll choose the default storage pool and create the volume. So as of now, just the volume has been created. We generally, if you were to use a Ubuntu host as an EC2 instance or whatever, you could manually or through automated means of Terraform, you will have to map this particular volume to the host, right? In this case, we are just creating the volume. The mapping and everything will be done by the CSI driver itself actually as a result. So right now, we've just created the volume. We need to note this particular volume ID. This is the most important thing. Because this is a statically provisioned volume, we need to know this particular volume ID. And in this case, I am just going to take this and put it in a notepad. Okay. There are some previous values I've been dealing with, so spare these. This is the volume ID that we just created in PowerFlex GUI. Okay, now the volume is created. We've gone past this step. In the blog, the volume ID may be different. This was done in a previous run, so just ignore that. Now there is one template that I've maintained. It's a YAML template. You can see AWS MySQL all-in-one.yaml. I'm not going to go through entirety of that template, but the point is that this template will deploy a PV, a PVC, a MySQL pod based on that PVC with the data directory persisted on it, an adminer pod, which is a web GUI kind of for database, connections and data exploration, and that is exposed through a load balancer, internal load balancer. So all that is there in this particular YAML template. You can use any workload as long as you retain the storage class of PowerFlex SC and provide the volume handle as the volume ID that we just created. It should be all good. So as of now, I'm just going to take these two commands and download this template into my cluster directory. Okay, and I will have to do one minor change, which is I'll show you nano AWS all-in-one. So all this is there. We create the namespace, the service for the adminer, and you can see that this is a internal exposed through an internal load balancer because the cluster is private actually. Adminer, leave it. Okay, you can see this particular the definition for the persistent volume, and because we are creating a PV or a persistent volume manually or not dynamic provisioning, we will have to provide it the existing volume ID as the volume handle. So this is the only change that I will perform. And if you plan to do this, creating persistent volumes, you will have to supply the volume ID based on what you gather from the PowerFlex system for the volume that you created. So I'm going to take this and just change it here. All this can be automated by simple bash commands. It's important to note these, so I'm just kind of manually doing all this. The remainder is basically a persistent volume claim that will be used by the MySQL pod here actually. Okay, so that the data directory is persisted on top of the persistent volume claim, which uses the PV there. Okay, so all of this is done. Now we can go ahead and create this particular template so that all the resources, they will get created. You can see that all of them have been created. The part which will interest us is if the MySQL pod is running. If it fails to run, means that there is some problem with either the pod itself or the container image, or the persistent volume could not be mapped, right? I mean, that's where it will be a challenge. You can see that since the MySQL pod has come into a running status, which means that it was able to successfully mount the persistent volume, which we can observe here, kubectl get pvc -n demo. So you can see that the PV claim is created, it's bound, the volume is this, the capacity is 8 gig, the storage class is PowerFlex SC. You can also see the PV itself, kubectl get PV -n demo, and you can see that same, the MySQL PV, we can describe this particular PV, describe PV -n demo, sorry about that. And we can see that the volume handle is this, which is exactly the volume handle that we have created for here. And suddenly you can observe a change also here. An automatic mapping has happened to the host. Now there are two worker nodes. Obviously, one of them would have been selected where the pod would have been placed, the MySQL pod, and the underlying host, which has the SDC client communicating with the PowerFlex STS, is now identified as the host, which is actually hosting this, or connected to this volume. You can see this as the host as well. You can see it's from our two IP addresses. This is the IP address where the the deployment and the CSI driver connection is observed for this volume. Okay, so far so good. Okay, what we will do now, the pod is created successfully. Let's do some sample data creation. So in order to do that, we will see what is the access for our Adminer GUI pod actually. So Adminer GUI is just a simple web UI running as a separate containerized application, and we can open that application and then connect to our database, which is the MySQL database here. Okay, so you can see that this is the IP, the DNS name for the internal load balancer. We will take this particular thing here actually. Okay, and paste it here. So you can see that the Adminer GUI opens up. If you work with Adminer, it's a very simple, easy to use. So the server name is MySQL. That's the name of the deployment. And because they are in the same namespace, we can refer to the server as MySQL itself, right? kubedns will internally resolve all of the nuances. The username that we have bootstrapped the database with is root. And the password is fake_password. It's all there in the blog, and we can just log into this database. So you can see that as of now, the defaults are present. There is no specific database that we have created. We can go ahead and create a sample database. Let's name it as cars. Okay, so now the database has been created. It's a blank database. We will use the SQL command here to populate some of the sample data here. So obviously all this is done. I've shown you all this. Okay, this is all done. Okay, we are here, right? Okay, so we'll take this SQL statements from this blog. Basically, it creates a table and populates some dummy data, let's say that, right? Okay, so let's go here, run this as a command. I'm inside of the cars database and I'm creating a sample data set here. Okay, so if I go back to the database here, so you can see everything is okay. If I go back here, you should see a new table called as car. Okay, if I go here and select data, okay, you can see that the entries for the sample data inserted are here. Now, why have we done this? We will quickly leverage the techniques to actually demonstrate the persistence, so that if I delete the MySQL pod and resurrect it, I should be able to see the data persisted, right? I mean, it's as simple as that. It's a very simple use case there, actually. Okay, now let's do this quickly. Let's go back to my blog here. Okay, so we will delete the deployment of MySQL. Do that. So now you can see that the MySQL deployment has been deleted. Of course, as a result of that, I should not be able to communicate with my SQL pod here itself. Okay, so you can see that name does not resolve, right? So the connection has failed because that particular pod has gone down. So obviously, the next thing would be to do is basically recreate the SQL pod. In order to do that, we can simply rerun the entire deployment of the template file. Now, what would happen is basically, there are other resources which have not been deleted. They will error out saying these already exist, but the one that is not there, which is the MySQL which got deleted, that will be recreated. Okay. Intention is basically, to make sure that when the SQL is remounted, MySQL is remounted, we should be able to see the persisted data, right? I mean, it's common sense, but let's just validate that. Okay, so all these are existing, so nothing, it just ignore these errors. The one that we are interested is MySQL deployment is recreated, and it's as simple as going back here, saying MySQL root take _ password login. We can see that the table exists and the data also exists. So persistence check, tick mark, done that. Now the next thing is basically volume snapshots, right? And this is where we will actually delete it could be a matter of corruption of the database, or it could be a matter of any other, nuance. If we have a volume snapshot created, we should be able to restore the database, while you can do this through Dell's PowerProtect Data Manager, which is a fantastic solution for integrated snapshot management and backup and recovery. Here we will try to do it manually, just in case you want to understand the volume snapshot capabilities here. So let's go here, okay, and we will, from the blog, copy this particular set of commands. Basically, there's a template file that I have to create the volume snapshot. Okay? And in the underlying framework, it will be basically using the external. Okay, for some reason, I lost my power in between. I hadn't connected the charger. Apologies. So I've resumed the recording here. Okay, so what I was saying is basically we will download this particular snapshot sample template. As you can see, the snapshot sample, this is the template itself. Okay. Yeah, so the template says basically this is the API version. The kind of it is volume snapshot, and the name is basically, I will have to change this name to suit whatever I do from how I manage my versions of the snapshot, how frequently I take my snapshot, what's my snapshot strategy. So here what I'm doing is just putting a sample strategy in place, which is, the name of the snapshot will be MySQL snapshot PowerFlex, and then suffixed by the date and the time. Okay. So I can periodically I can use a bash, I can use an external tool, or whatever other mechanisms, but this is just a snapshot sample. So I will download this template. Okay, let's take this template from here. Okay. And I will download it here. Okay, so if I look at the contents, I should have now the snapshot sample here. Yeah. So I'll edit this particular file, nano snapshot sample. Okay. And here in the date time, I will just put today's date, 2024, or let's say it's 4th of March, so 0403 2024, and the time locally in Ireland is 1655, 1655. Okay, so it just gives me a point in time reference. Okay, let me also change this, the label here. Okay, and you can see that the volume snapshot class name, which will be used to create the snapshot, is VxFlex OS-snap class. And if you recall previously, this particular snap class will use the underlying CSI driver from PowerFlex. Let's view that. kubectl get volume snapshot class. And you can see that this particular snapshot class uses again the driver, which is CSI VxFlex OS for the PowerFlex Software Defined storage. So now if we create the snapshot, it will be using this snapshot class and the underlying driver to create a volume on the PowerFlex Software Defined storage. Let's validate that. kubectl create -s snapshot sample. Okay, so you can see that this particular snapshot has been created. We can also validate the snapshot. kubectl get volume snapshot -n demo. You can see that this is the snapshot name that we had put it in the template. The source PVC is this, which means it's the PVC which has our database and the sample data which is inserted in that actually, right? Let's also view the kubectl get volume snapshot content -n demo, which is the actual content. You can see that this is the snap content. Okay, let me describe this to give you a better picture of what I intend to show. Describe volume snapshot content. You can see that by creating this volume snapshot and the content, a new volume should have been created in PowerFlex with this volume handle. This is a new volume which will have the snapshot content basically into it, right? So now we should have two volumes seen inside of PowerFlex. One, the original volume in which the data is running, or the MySQL pod is running and serving. And then the snapshot of it, which is persisted as a separate volume. Just in case we delete or the original volume or it gets corrupted, we can recover from this particular snapshot. This is the volume handle. And the other thing that the UID. Yeah, these are the two things that we can use to correlate. How do we do that? Let's go to our PowerFlex. Not mandatory, but we can actually just kind of view and correspond those values. Now, As of now, you can just see that this is the originally provisioned volume, MySQL static provisioning. This is the volume handle, but there is a filter here that you can use and remove this filter volume. And you should be able to see the snapshot content also. So you can see that it starts with the prefix of SN. Importantly, see the volume ID ending with 05, and we should be able to corresponding it here. Volume handle is this one. Sorry about that. What was real? Okay, snapshot handle 05. Yeah, you can see this one here actually. 94 AE, AE4, and all zeros and 5. You can see it here. 94 AE all 05, right? And the way it is described here is basically the system ID of the PowerFlex array hyphen and this particular thing, right? And then there is a UID here, which is this particular value. Let's see if you can see it here somewhere. CF773. Can I see it here? Let me see. Okay. Anyway, yeah, this one. So you can see this value here, CF73E6 and all that. And you can correspond it to this value. SN is the prefix. We can change this prefix also if you want, but the prefix, whatever is the default has been put here, and then, hyphen the UID of the one. So it just basically helps correspond these two things from a GUI perspective and from a native kubectl perspective. So now, as of this stage, we do have a database and with sample data populated in it. And whatever the data is, we have taken a point in time snapshot of. How do we validate if this snapshot actually works, whether it's legit, and whether it can help mitigate the risks actually. So in order to do so, we will delete the existing volume, the persistent volume, and then recover the MySQL database from this snapshot. In order to do so, back to the blog so that we are clear. Okay, so we finished this. Okay, we've created the sample snapshot. We have done the description of that. I've shown you already. I've shown this snapshot inside of the GUI as well. Okay, so now what we will do is we will start with deleting the MySQL deployment itself. Okay, so this is deleted. We will delete the persistent volume claim itself. This is for the original volume that we created and the PVC that we created for that. So that's deleted. We will delete the original PVC or the PV also. Okay. Delete this. So now all these three resources are deleted from the Kubernetes namespace demo. Okay. And now if we go here and let's just refresh this. Ask this. Now we will delete the, note that if this was a dynamically provisioned volume, this particular volume should have also been deleted. Now we have done this in a statically provisioned volume mode. So the volume remains, the Kubernetes resources have been destroyed. We will delete this volume also, the original volume. Note that our data which is persisted is actually inside of this volume, right? So we are deleting this. So it's like, boom, everything is done, deleted. Okay, so you don't have anything except for one volume which was created as a reference output of a snapshot. And this, as per all the assumptions here, that whatever we have done, the data, the sample database that we created with the table cards and all that is populated in this snapshot because this was taken point in time. Note that as of now, this is just a volume like the previous statically created volume, no host map here. Now, in order to demonstrate restoral, we will go back to my blog. Okay. Now note the volume ID. So we can see here, I'm just mentioning, we have to make a note of this volume ID here. So let's take the volume. Okay, before that. Yeah. So let's take a note of this volume ID. This is now the volume ID for the snapshot one. Okay, put it in a notepad somewhere so that it will correspond nicely. Okay, now we will edit the deployment YAML. Note that in the first case, when we started blank, we had given the original volume ID as the input for creation of the persistent volume. Now we will be using the volume ID of the snapshot volume to rebuild the persistent volume inside of the demo namespace. Okay, so if I edit my YAML for the deployment of MySQL and the PV and all that, you can see my previous volume handle was the original volume that we had created. I will change this particular volume handle to the snapshot volume handle. Okay. Done. Now note that we've just deleted the MySQL deployment, the PV claim, and the PV definition. We still haven't deleted the adminer. We haven't deleted the service type for that and all that. So once we apply all of this, blah, blah, blah. Okay, so the three resources which were deleted have been recreated. The others, they are already there. So just ignore this error. Okay, so all this is now recreated, which means if I see kubectl get pods -n vxflex OS, sorry, not OS, dem. That's the namespace our application is running, or that MySQL pod is running. Since the MySQL pod has come back into action, it's in running state, we can safely assume that the persistent volume claim is rebuilt with the underlying PV, which is using the volume handle of the snapshot volume that we see in the PowerFlex GUI. Which means that if I now log in into Adminer and try to access this database, or this particular database instance, we should be able to see the cars database with the table car and the sample data which is populated inside of that. Let's validate that. How do we do that? We go here, we go here, we go here. Let me refresh it, that's better. From the start, so that if any cookie or anything is there, should be getting rid of it. Okay, so MySQL root fake password, login. Okay, so good news, we do have the volume handle or the persistent volume regenerated from the snapshot volume. It has persisted the data, which is the cars database, the car table, and okay, the data is also there. So, I mean, there's a lot more we can do, and hopefully I'll document some more test use cases there. But practically speaking, what we've done is, not only did we create the EKS cluster, the node group, which has the SDC clients for the Apex block over AWS storage, but we also ended up in deploying a sample workload, persistent workload through MySQL. We have shown the persistence by deleting the MySQL pod and bringing it back on by remapping the volume, so that persistence was tested. B, we have also tested the volume snapshot creation and restoration of the database through revamping of those snapshot volumes. I hope all this was informational, and at the end of the day, I wanted to show how easy it is. Although it's, again, to reiterate, it's been a long, detailed video, but actually what did we do? We downloaded some templates for Node Group. the cluster, the node group. We deployed the EKS cluster and the node group, simple commands. There's a bootstrap script already in there for automation for implementing the SDC client. So that takes care of the SDC client installation. Then what did we do? We deployed the CSI driver, again, a short script there, given some rough inputs or some inputs that it expects, and the CSI drivers got implemented. And after that, what's it? You just got to deploy your sample workloads there. That's it. I hope this brings some benefit to you. Thank you. Cheers.